Vulnerability research hits the wall, and then the wall moves. The economics of exploit development just changed on a timescale that should alarm anyone responsible for patching anything. Thomas Ptasek's Vulnerability Research is Cooked is the most important essay on the state of offensive security published this year, and the thesis is blunt. Frontier LLM agents are about to supplant most human vulnerability research, not augment it, supplant it. Ptasek draws on a conversation with Nicholas Carlini at Anthropic's Frontier Red Team, who described a deliberately simple pipeline. Loop over every source file in a repository. Spam the same Claude code prompt. Find me an exploitable vulnerability, start with this file. Then feed each candidate report back through a second run to verify exploitability. The success rate on that verification step, almost 100%. Carlini aimed the pipeline at Ghost, the popular CMS, and it produced a broadly exploitable SQL injection. No custom tooling, no fuzzers, no model checkers. Just the model, reading code, and reasoning about reachability. Ptasek's framing is Sutton's bitter lesson applied to security. Researchers spend 20% of their time on computer science and 80% on giant jigsaw puzzles. And now everybody has a universal jigsaw solver. The implications Pcheck draws are structural. In a post-attention scarcity world, exploit developers won't carefully pick targets. They'll aim at everything: routers, printers, hospital imaging systems, the inexplicably networked components of a dishwasher. The load-bearing risk assumption that elite talent won't bother with unglamorous targets no longer holds. He's equally worried about regulation, that a wave of AI-accelerated ransomware incidents will produce incoherent computer security legislation drafted by policymakers who don't grasp that unregulated open-weight models will have the same capabilities in 9 months. As confirmation, the Caliph.io team reported finding RCE 0 days in both Vim and Emacs simply by prompting Claude to look. Vim patched immediately. Emacs maintainers declined, attributing the issue to Git. The team has launched Mad Bugs, Month of AI-Discovered Bugs, promising more through April. Silent memory pollution. The zero-click agent attack surface. If exploit agents are the offensive problem, a new paper from NTU, Astaire, and Johns Hopkins identifies a defensive one that's arguably harder to fix. Persistent AI agents can be silently poisoned through their own background execution loops, with no prompt injection required. The Heartbeat paper formalizes what the authors call the exposure memory behavior EMB pathway, demonstrating that misinformation encountered during routine heartbeat-driven background monitoring. Checking email, browsing social feeds, scanning GitHub issues. Enters the same shared session context used for foreground user interaction. From the LLM's perspective, a heartbeat tick is just another user message. The numbers are sobering. Using Mistclaw, a controlled research replica of the Moltbook agent social platform, the researchers evaluated OpenClaw agents across software security, financial decision-making, and academic reference tasks. Social credibility cues, especially perceived consensus, drove misleading rates up to 61% in the short-term setting. Routine memory-saving behavior promoted short-term pollution into durable long-term memory at rates up to 91%, with cross-session behavioral influence reaching 76%. Under naturalistic browsing conditions, where manipulated content was diluted among benign posts and had to survive the system's own context pruning, pollution still crossed session boundaries. The attack requires no direct interaction with the victim agent. Place credible-looking misinformation where the agent is likely to encounter it during background activity, and the content enters as ordinary information rather than an overt control attempt, making it less likely to trigger safety guardrails than explicit prompt injection. 3 properties make this especially dangerous. Weak source distinction. Heartbeat-acquired content isn't separated from user-provided information. Limited user visibility. The triggering exposure may never surface to the user, and provenance-free memory promotion. Externally encountered content gets written to long-term memory without source attribution. The paper illustrates this with a concrete scenario. A poisoned post claims a library has a critical RCE and recommends migrating to a malicious replacement. The agent absorbs this during background scanning, saves it to memory, and later presents it as known issue knowledge. Source laundered, provenance erased, user grateful for the warning as they install the attacker's package. The vulnerability is architectural. As long as Heartbeat ingests untrusted content in the same session used for foreground interaction, silent memory pollution follows from the design itself. Meanwhile, on the inference infrastructure side, VLM disclosed C VLE2026 27893. 2 model files hardcode trust remote code =sign true, silently overriding an explicit false setting with no warning. A malicious Hugging Face repository targeting Nemotron VL or Kimi K25 can achieve code execution on the inference server. This is the 3rd time the same vulnerability class has surfaced in VLLM, each time in a different code path. Versions 0. 10.1 through 0.17. X are affected. 0.
18.0 contains the fix.
Agents as the security response. Exposure management goes agentic. The same agentic architecture that creates new attack surfaces is now being deployed as the security response itself. Tenable launched Hexa AI, the agentic engine powering the Tenable One exposure management platform, featuring a fleet of mission-ready AI agents that coordinate human approvals and automated workflows into a single orchestration layer. The pitch: in the time it takes to read a blog post, an AI-assisted attacker can scan an environment, gain initial access, move laterally, and breach sensitive data. Tenable cites Anthropic's November 2025 disclosure that a threat actor jailbroke Claude Code to automate 90% of a targeted attack at machine speed. Hexa AI responds with assessment configuration agents, asset categorization at scale, risk intelligence agents, contextual dashboards on demand, and advanced workflow orchestration. All with Model Context Protocol MCP built in as a universal adapter so customers can connect business tools to any LLM. The human-in-the-loop dial is adjustable. Full autonomous execution or strategic manual oversight, with everything logged for audit. On the regulatory side, Regentel takes a different angle on agentic security. An AI-powered CLI that automatically researches, stores, and manages a global inventory of penetration testing regulations for financial services across 20-plus jurisdictions. The architecture is a 4-agent LangGraph pipeline. Research GPT-5.4 Mini for web search and extraction, validator rule-based pre-checks plus LLM validation, Reflection LocalQuen 3.5 122B running a quality gate with hallucination detection, and Persister database writes with change detection diffing. Every new regulation must pass through the Reflection quality gate before reaching the database, and a Chroma D vector store enables semantic search across the regulatory landscape. The dual model approach, cloud for speed, local for verification, is a practical pattern worth watching. Trust, containment, and the add in your pull request. A quality engineer in Serbia opened his assessment tool last Tuesday and found 95% test coverage on a module for which he had not written a single test. The number was fabricated, stitched together from fragmented key conventions and stale snapshots. 5 different key formats existed for the same concept. None talked to each other. The score consumed whichever fragment it found first and called it truth. Dragan Spiridonov's The Witness Stand essay argues that the standard approach to agent trust, better prompts, more guardrails, human-in-the-loop review, is a hope architecture. And that classical testing solved this problem decades ago. His prescription: replace JB2 hashes with SHA-256 for tamper-evident witness records, enforce deterministic YAML pipelines that execute without consuming a single LLM token, and deploy SUSUM drift detectors that watch for statistical shifts continuously. Stop building trust. Start building evidence. The containment problem is getting its own tooling stack. Stanford's AGI is a one-command casual sandbox for Linux that gives AI agents access to a working directory while keeping the rest of the home directory behind a copy-on-write overlay. The motivation is a growing catalog of horror stories. 15 years of family photos deleted via terminal, Claude Code wiping a home directory, Cursor emptying a working tree, Google Anti-Gravity wiping an entire drive. AGI offers 3 isolation modes from weak most files readable to strict home hidden, with no Docker files or 40-flag BRAP invocations required. The developers are explicit. This is not a promise of perfect safety, and it's not equivalent to a hardened container runtime. It fills the gap between giving an agent your real account and stopping everything to build a VM. And then there's the failure mode nobody quite anticipated. GitHub Copilot editing an ad for itself and raycast into a developer's pull request description after a team member summoned it to correct a typo. The developer's reaction invoked Cory Doctorow's enshittification framework. Platforms are good to users, then abuse users for business customers, then abuse business customers to claw back value. When the tool writing your code is also selling you products inside your own PRs, the trust calculus changes in ways that guardrails and sandboxes can't address. Harness engineering, when agents optimize their own scaffolding. The most technically interesting agent research this week comes from Stanford and collaborators. MetaHarness, a system that learns to optimize model harnesses. The system prompts, tool definitions, completion checking logic, and context management that wrap a base model. By giving a proposer agent access to a file system containing the full source code, scores, and execution traces of every prior candidate. In practice, this means up to 10 million tokens of diagnostic context per optimization step, versus at most 26K for prior methods like OpenEvolve or TTT Discover. On Terminal Bench 289 Dockerized tasks spanning code translation, distributed ML, systems programming, bioinformatics, and cryptanalysis, MetaHarness achieved 78.2% pass rate with Opus 4.6 ranking number 2 among all Opus agents, and 37.1% with Haiku 4.5 ranking number 1 among all Haiku agents, outperforming the next best agent Goose at 35.5%. On text classification, it hit 51.7% versus ACE 40.9%. a 26% relative improvement using 0 additional LLM calls. The key insight: most program search methods compress history into fixed prompt formats, discarding the execution traces that targeted diagnosis requires. The adversarial development pattern is going mainstream. A detailed walkthrough of building GAN-inspired coding harnesses, where a generator agent implements and an evaluator agent rips apart the implementation across negotiated sprint contracts, demonstrates the architecture producing polished full-stack applications in single shots with Sonnet 4.6 that Opus 4.6 couldn't match without the harness. The harness enables cheaper, faster models to produce better results than expensive models flying solo, which inverts the usual just use the biggest model calculus. On the open source side, Planner Agent v3 for OpenWebY brings hierarchical sub-agent orchestration to self-hosted setups. A base model acts as planner, decomposes tasks into a dynamic task tree, delegates to specialized virtual sub-agents web search, image generation, knowledge/RAG, code interpreter, terminal, and executes in parallel via syncio.gather. State persists across turns via JSON attachments, and MCP support includes deduplication and deadlock patches. Apple Silicon crosses the research threshold. The local AI story on Apple Silicon has quietly crossed from hobbyist tinkering into credible research infrastructure. The Mac Code project demonstrates a Claude Code-style agentic coding assistant running a 35B mixture of experts model at 30 tokens/second on a 16GB Mac Mini M4. Entirely free, using llama.c, PP with Unsloth's IQ2M quantization. The more technically interesting contribution is flash streaming, a technique that splits models by access pattern, pinning attention weights and embeddings in RAM 4 to 6 GB while streaming FFN weights from SSD per token, layer by layer, discarding after each matmul. For MOE models, only the 8 active experts about 14 MB load per token instead of all 256 about 460 MB, yielding 10x speedup over dense streaming. The project runs a 22 GB model on 16 GB of RAM at 1.54 TOC/s with 1.42 GB resident memory, and a batched union of experts prototype hits 5.1 TOC/s by computing the set union of active experts across 8 verification tokens. Key discovery: FNOCACHE. DirectI/O is 27% faster than AMR macOS because it bypasses the unified buffer cache. Karpathy's auto-research concept has been ported to MLX, enabling autonomous research loops natively on Apple Silicon with no PyTorch or CUDA dependency. The protocol is elegant: one mutable train.py, one metric val BPB, a fixed 5-minute training budget, and keep or revert via Git. Overnight runs on M4 Macs pushed val BPB from 1.807 down to 1.294, with the Mac Mini finding a meaningfully different optimal configuration than the Mac's class machines. More aggressive step efficiency wins, a hardware-specific behavior the loop is designed to surface. On the quantization front, an adaptation of the TurboQuant algorithm from KV cache quantization to model weight compression achieved effectively lossless 4+4 residual coding at 8 total bits. QWEN3.54B scored 10.70 perplexity versus 10.67 baseline, with KLD of just 0.0028. The community is already testing llama.c, P integration via Walsh-Hadamard transform fixes. Alibaba released COPA9B, an official agentic fine-tune of QWEN3.59B that benchmarks on par with the much larger QWEN3.5+ on several tasks, and Unsloth's QWEN3.527B fine-tuned on distilled Claude Opus 4.6 reasoning data has held the #1 trending spot on Hugging Face for 3 weeks running, hitting 36 TOC/s on an RTX 3090 with Q4K-M quantization at 128K context. Voice models, trading agents, and the $500 K rewrite. A V3 medical speech-to-text benchmark across 31 models on the Premach 57 dataset 55 doctor-patient consultations. About 80K words of British English medical dialogue crowns Microsoft's Vibe Voice ASR9B as the new open-source leader at 8.34% word error rate, nearly matching Gemini 2.5 Pro's 8.15%. The catch: Vibe Voice needs about 18 GB VRAM and processes at 97 seconds per file, even on an H100. The real edge story is NVIDIA's Parakeet TDT 0.6 BV3. 9.35% were at 6 seconds per file on Apple Silicon, a 0.6B model within 1% of a 9B model. The benchmark also uncovered bugs in Whisper's text normalizer that were quietly inflating were by 2 to 3% across every model tested. O was treated as 0, and common equivalences OK/OK, yeah/yep/yes weren't normalized. On the generation side, a reverse engineering effort recovered the missing codec encoder weights from Mistral's open-source Voxtral 4B TTS model, unblocking the reference audio pass required for zero-shot voice cloning. The community response was immediate interest in fine-tuning on larger single-voice datasets rather than relying on zero-shot capability. NoFX is an open-source autonomous AI trading assistant built in Go and React with a genuinely novel payment model. X402 micropayments via USDC wallet instead of API keys. The system supports 15+ AI models via the Claw 402 gateway, 9 exchanges including PerpDex Hyperliquid, Aster and Lighter, and features a strategy studio visual builder, AI competition mode with leaderboards, and a Telegram agent with streaming and memory. The fully autonomous claim means the AI selects which model to use, what market data to pull, and when to trade. The user sets strategy and funds the wallet. Rico.ai reported rewriting their JSONATA evaluation engine with AI assistance in a single day, saving $500K annually. The original JSONATA library, responsible for evaluating policy expressions across their SaaS security platform, had become a performance bottleneck processing millions of rule evaluations daily. The AI-assisted rewrite replaced interpreted evaluation with compiled, optimized code paths, turning what would have been a multi-quarter engineering project into a weekend exercise with production-grade results.